Hello everybody, FunshineX here. Welcome back to my ComputerCraft series on the game I like to call Keep Coding and Nobody Explodes, based on the popular new game called Keep Talking and Nobody Explodes, where you have to defuse a bomb. We're making a clone of that game in ComputerCraft with inside Minecraft. Last time, we worked on our display and our strike counter, and we got the 7-segment display working, so go check out that episode if you missed it. This time, we're going to work on our first diffuse module, which is going to be the button module. How this works in the game is you're given a button, circular button, that is a certain color, random color, and has a word on it. It could be detonate, could be hold, could be press, could be abort. I don't know, there's a bunch of different words it can be. Now, based on what it is, you're supposed to press the button, and then certain colors will light up, and that determines when you're supposed to release the button. There's also some outside factors that determine the logic, such as batteries being attached to the briefcase or indicator lights being lit. We're going to try and do all that. Before we get into the coding the module, we have some bad news. The way I intended this to work was we would create each of the modules kind of like separately on their own. You know, maybe all 11, or I don't know how many different types there are. And then we'd use a ComputerCraft command turtle to kind of copy paste the commands into the briefcase so that they would be kind of random every time. The problem is ComputerCraft supports up to Minecraft version 1.7.10. The Minecraft command clone was added in 1.8. So you see my conundrum. I can't clone a section using a command line or a command block command until 1.8, but ComputerCraft doesn't support 1.8. So we're going to have to switch gears just a little bit, and maybe if Dan ports my ComputerCraft to 1.8 sometime in the future, we can change and make it work a little cooler. But I think we can still make it fun and make the game randomized, that kind of thing. So just realize we're going to have to travel a little bit further away from the actual game and how I wanted to do it and how it looks to kind of what we have available. I still have this guy. He's making it noon for me all the time. Every 30 seconds he sets the time, so that's not a bad computer to have. Okay, so let's talk about this, how we want this to work. We're going to say, let's just take this whole section here, and let's do a set 15, 9. Nope, that isn't right. 159.9. There we go. All right, and then I think we're just gonna have. Do we have an? This is 166.4. Yeah. So from there to there. Oops, that's not gonna work. All right, we're just gonna have to manually set the monitors up. But what we're going to end up doing is all of the modules are just going to be a 5x5 ComputerCraft monitor. And depending on when we start up, the user will select like a difficulty mode or, you know, a number of modules they want to do. And then it'll randomly run that many modules in random locations. So maybe the first time you start up, it's like, oh, you want one module, I'll put a button module here, or I'll put the wires module here. If you have like 5 modules, it might fill in this one and run a program on that one and different things. So they'll all kind of look the same, which is unfortunate, but it's going to have to be how we do it. Okay, so here's our sample module. I can't stand these stupid bats. Oh, that was nice of him. The /kill entity command is also in 1.8. Ah, bummer. Okay, let's go ahead and put a computer here. Just, again, we'll put it in front so we can see what we're doing while we're working on it, and then we'll move it and hide it behind itself. So let's edit this program, and this is going to be called the button module. And I'm going to go ahead and save it and then exit out of it. And I'm going to go outside Minecraft really quick and just copy in a little bit of code that I've written ahead of time. You can see we've got a few commands. So we've got these are kind of like the logic, or the kind of the game variables, the different things that it can set up with. So the words that it can print on the button, things like abort, detonate, hold, we could add more. You notice that I add exclamation marks on these two. That's just to keep the word an odd number of characters so that it centers better. ComputerCraft is not the best when it centers text. It's an integer-based position, so if you have an odd number of characters or even number of characters, it doesn't center, right? Does that make sense? Anyway, so by adding an exclamation mark doesn't change the the game any, but it allows me to make it look better. The different colors of the button, the game allows blue, white, I think there's like red, yellow, I don't know, we could add more if we wanted to. And then here's how I'm going to change the game. Instead of pressing and releasing the button, because let's say this module was way down here, if you press this button, right-clicked on it, oops, if you right-clicked on a button and then you're supposed to release it at a certain time, there's no way you could then see the clock at all. So I think it's best if we just do a single press. We'll change the state from like off to on, change its color, and then and then you can come back and look at the clock and be like, okay, 3, 2, and then click it, right-click it again to turn it off. So that's kind of how we're going to edit this to work with our limitations. So I have the button colors that the button can start with, and then when you turn it on, it will turn a different color, and then based on what color it turns will be, when you need to turn it off. That's how the diffuse of this works. The number of batteries, right now we're hard coding it to 0, but the way I'm going to work that is the game controller, which will be the main computer running right here, is going to, at startup, determine a random number of batteries. And we're going to have a bunch of monitors along the outside. So we might be like right here. Just have a monitor. Oh, not a computer. A monitor. And on that monitor, we'll just print a picture of a battery or something. And there might be another one here that's like a double battery or something. So that way we can randomly have a number of batteries, and you'd have to go look at it and say, okay, how many batteries are on this thing? And you have to kind of fly around and look. So that's kind of the plan for the batteries. The same thing with the indicators. I'll have some things, like right here. It'll be like a text box, and it'll have a word, and then we either lit up or dim or something like that. So you know how many indicators there are, or which indicators. If you haven't played the game, that might not make any sense to you. Go watch who's playing this game? B-Dubs is playing it right now. Okay. So right now I have number batteries 0, and then I have a table of all the possible indicators, and I'm setting them all to 0 as well. So right now they're hard-coded, but we can randomize that later. Okay, so that's just kind of our initialization of our game variables. Then we've got a few other things that we want to do. We want to kind of store what... We want to randomize from these choices, obviously, and then store what the randomizer picks. So we'll have one called the game word, and that's whatever word it picks, abort, detonate, whatever. And we'll have the random color, so I'll call that the game button color. And I'm going to initialize these. This will be initialized to empty string. This will be start at colors.white. Same thing with the on color. And then we could do what state the button's in, either off or on. So it will start in off. Okay. Next, we need to initialize the monitor. So let's do a comment here. And we'll say which side is the monitor on. So screen side equals, I think we're on the top, right? Of our computer, and we've got the actual peripheral. So button screen dot equals peripheral dot wrap, and we'll do the screen side. Okay, so that finds where our monitor is and wraps it, and then we'll kind of do some like initial clearing of it just in case there was something on it from before. So set the background color, because it's going to change throughout the game. We want it to always default back to black. And then we'll do clear. So that's resize it. And then we'll initialize our text scale. And I tested and I liked the value of 4. Remember, you can go from 0.5 up to Is it 5 or 6? I can't remember the maximum is, but 4 seemed a pretty good size. It could fit the word detonate, no problem on there. Okay, so that's kind of our initialization of our monitor. Doesn't really do anything yet. Now let's have a bunch of functions that we can call. I didn't really do that in the last program, but in here it's quite necessary because we're going to be calling these over and over and over again. So the first one I'm going to call, well, we only call it once, but it's a startup, during startup, is to find the random values. So I called that get random game values. And that really doesn't take anything in there. And that function is going to do all the randomizing. So our game word is equal to, we take that words table or words array, and then we need to pass a random integer into that. So math.random. And it can be the size from 1 up to the size of the table length of the array. And to do that, you just do a hashtag and then the name of the table. So that will give us a random word from that words table. We can do the same thing with our button color, and that's from button colors table, size of button colors. Okay, and same thing again. We'll do a game button on color. Oops, button. I probably could just have one button colors array, but I think the game actually has different colors of the button and what the indicator flashes, so it'll be all right. Button on colors equals math.random hash button on colors. Okay, if I don't have any typo in that, that'll be a miracle. And that's all that function does. So we can leave it like that. And the next one function I want to use is one, this is probably one I'll move to an API because I use it quite a bit, and that's printing text centered on a monitor. We do that all the time, and it's just, let's put it in a function for now, maybe move it to an API later. So that's going to be called print centered. I'm amazed this is not part of the default ComputerCraft API, but that's fine. And that one's going to take the monitor that we want it to print it to and the actual text that we want to print. And in there, we're going to get the width and the height of the monitor. Get size. That's just a ComputerCraft thing. And the y coordinate that we want to write to is going to be the let's see, the height of the monitor divided by 2. But remember, in ComputerCraft, division can return a decimal. We don't want that. We want an integer. So we're going to do math.ceiling. That makes it round up. And then we're it just looks better if you go down one line, because monitors have a even number of lines, so you can't really center it. That's okay. Then let's see. Let's do the x coordinate that we're going to write to. This one is a little complicated, but basically you're going to take the width of the monitor, oops, and divide it by 2, and that will give you the center, right in the middle of the monitor. Now we're going to subtract half of the text that we want to print, so it goes, finds how far over to the left we need to go. So that's the length of our text divided by 2. And that could return a decimal value. So we'll do math dot, let's do a ceiling on that one as well. Looks better. And then I'm also going to add 1 just because we're using odd values. So we want to align it 1 more over. Otherwise it would, I don't know. It looks better. Trial and error, I found that works the best. And then the other thing, we want to cover the case that there's perhaps the text is longer than the width of the screen. And to fix that, we do math.max between the value we just calculated and 0. So if ever this value is negative because this text was too big, then we'll start it at the 0 at the far left of the screen. That shouldn't happen in our case because detonate is the longest word and it will fit easily. That's good. And then all we do is we do mon.set cursor position, X, Y, and then mon.write and write our text. Cool. And that's the end of that function. Okay, next one we want to have is to actually print the button on the screen. So let's do print the button. And this is going to take a state, and that's going to be either off or on because it's a different color. And we'll store a variable for the current color. And that will default to, what did we call it? We called it the game button color. And remember, that's the color that it is when it's off. And then if it's on, so if the state of the button is equal to on, then we'll, oops, missed a then in there. Current color is equal to game button on color, and end that if statement. So that way it's either the game button color or the game button on color. Either way, it's set in current color, so we don't have to worry about it anymore. And we'll go ahead and set the button screen's background equal to the current color, and then clear it. Okay, so that should make a random color on our background. That's all it does, which is fine. The next thing we want to do in here is print the word, the random word. So let's say button screen. First we gotta take care of the font color, because if the background is any color but black, we can do white text, or we can do black text anytime except when the background is black, so then we need to do white. So our default button screen dot set text color is gonna be colors.black. That'll be our default color. But just like we did above, if let's see, but what's the check? If current color, because current color is whatever the background color is black, then we will do button screen. Oops, I did that totally wrong. It's hard to type and code at the same time, guys. I'm sure everybody watches me sometimes. They're like, why did you type that? But anyway, it'll be colors.white. That way the text never fades into the background. We need to put an then in there and an end on that statement. Okay, now we got the correct color set, so all I have to do is call our print centered function. And we passed in the monitor, which is the button screen. And we passed in what word to print, which is game word. Okay, that should print that on there. Hit save on this. Okay, before we get into any of the other kind of stuff, let's just go ahead and write our main program. And this is how I always like to do it. I declare main and then call it. So it's easy it'll always run, and we can call it again. All right, so in the main program, we're going to go ahead and first call that get random game values. Okay. The next thing we want to do is print the button, and this is going to be in the off state, which is just whatever's in button state. Then we'll do something here, input mouse. We'll put that in later. And once that occurs, once that mouse event occurs, we'll set the button state equal to on and print the button again. Then we'll do the same thing. We'll wait for input. And then we need to do, run game logic. And this is basically going to say, what color was the button? What word was on it? What time did they press it? Was that successful? And it'll return a true or false. And so based on if true, we'll call some kind of message that they diffused it. Or if it's false, then we'll call send fail message. And those will be over a wireless modem back to the main game controller. And it'll say, okay, they succeeded on this one, click, check, or they failed, they get a strike. If 3 strikes, they're out and the whole thing explodes. Cool. All right, main get that should work. Let's just go see if I have any typos or if we get something. All right, division nil and a number at line 44. What did we do here? No, I don't remember dividing anything. Oh, I'm dividing it in here. H divided by 2. What have I done? Did we not? Well, we definitely initialized the monitor. Mon is button screen, right? Okay, well, I've got to troubleshoot a little bit, guys, so I'm just go ahead and pause it here and be right back with whatever typo I had. Okay, guys, found the silly typo. I just missed an equal sign right there. I'm sure you guys saw it when I was typing, but again, while I'm talking and typing, I usually make mistakes. So let's try running that again. And there we go. We've got a random color and a random word in the middle. Prints black. If we run it again, we've got a different color, printing black again. Let's do it one more time. Red and black. I was trying to get the background to be black, but it doesn't look like it's going to happen. Cool. All right, so there's our random colors and our random words. So the next thing we need to do is detect when the user clicks on the screen and change it to an on state. So let's write that. That we'll put in another function just right above main here. And we'll call this one, how about something like wait for user or get user input maybe? Get mouse, well, it's not going to be user or mouse because we're going to use the same function to receive modem messages of what the current time is. So let's just call this get message. Okay. And in here, we'll worry about the modem messages later, but for right now, we're going to do, let me get my sample code up here. The os.pull event command. Basically, this is a way to have your program pause until certain events are fired. And so we're going to do an os pull event, and that returns a number of parameters, I guess. And so the first one is the type of event, and that's really the only one we care about. If I was worried about where on the screen they clicked, then I would get more. I would, do comma, and then there's like, oh, come on, like the key 1, key 2, or something, X1, X2. There's different, like, what button was pressed, all that kind of stuff. I don't really care about that. I just want to know what the event was when we pulled it. And then we will do, that was the pull event, if, let's see, we'll say event like that. No. I want to call this over and over and over again. So let's do while true do. How about that? So that's just going to call it forever. No. And end. So that's going to be a loop forever. And how do we get out of that? That's basically if the event is equal to its modem, no, monitor, touch. Then we break out of this event. I didn't put it then, did I? Okay, so that will just keep pulling events until we get a monitor touch event, and then it will end. And then we're going to call this here get message, and we're going to call it again here. Okay, save that, run it. Oops, we're missing a then. Okay. Oops, what line was that on? 72. my C# Java is coming in to Lua, and that's not good. All right, there we go. So now it's white. If I right click on it, it turns to its other color. Right click again, and it should end the program. Cool. And we probably want to wrap, let's see, let's go up to init the monitor and put this inside a function here. We'll call this init screen. I don't know. That way, what we can do is end here. Let me tab real quick just so it looks pretty. I wish there's a scroll bar here. Page down work? Oh yeah, page down does work. Awesome. In the main, we'll do init screen. And then we'll also do that right at the end, just so it clears it out. Okay, random color, right click on it, random color again, clears it out. All right, so now that was a problem. The off color equaled the on color. I got a solution for that. What we'll do in this get random game values is we'll keep calling that. So while the game button color is the same thing as the game button on color, we'll just keep calling this. It's probably not the most efficient. Well, it is definitely not the most efficient. Because that, you know, that technically, if you hit the right random number generator, could run forever and never pick when it would always pick the same colors. But we've got 4 or 5 button colors and 4 or 5 button on colors, so the chances that they're the same is like 1 in 5, 20%. So most this would have to run is like, I don't know, like 5 times. I'm making up that probability. Okay, I'll just separate these a little bit so it's easier to see what they're doing. And save it again. Oops. Again, typing and talking at the same time. So now we should never have the case where they're the same color. Sweet. So that's pretty much it for our module. Now we only need to put the logic in there. And I think we're going to do that as a part 2, where I will, well, it'll technically be episode 3, where we'll go ahead and update the main game controller to start sending out modem messages, and our module will start receiving them. And then we'll go ahead and connect them so that when this is successful, you get some kind of message, you know, the success. But if it's a failure, then it will send a strike over here, and then we'll implement the 3 strikes, you're out type thing. So that'll be episode 3. We'll kind of get these two, the timer and our first module, talking to each other. And then after that, we'll move on to our second module, which will probably be the wires, or maybe one of the like the symbols ones. I'll try and pick some of the easier ones to start out with, and we'll get more complicated as we go. All right, guys. Well, that's it for this episode of Keep Coding and No One Explodes. If you guys liked it, make sure you hit the like button. Tweet out to Dan200 that you really want ComputerCraft to be in 1.8. I know he says he's too busy, so it's probably not going to happen, but we can bug him, right? No, we shouldn't bug him. Subscribe to my channel if you want to see more. Make sure you go check out this the real game, Keep Talking and Nobody Explodes, on their website. Buy it from Steam and play it. It's a lot of fun. And I'm no way sponsored by them, so I'm saying that just out of my own free will. Hope you guys enjoyed. I'll catch you in the next episode. Bye.